Hello, welcome back to the continuing lecture in simple interest. Now, we had one question left in the last segment. Now, these two cells, the yellow highlighted cells, which is principal. Now, our question is then quite obvious. If the future value is given, in other words, future value is known, and interest rate is known, time is known, what should be the principal? How do you solve for principal? Well, in other words, if you need $2,220 in 20 years, when the prevailing market rate is 10%, what should be the principal? In other words, what do you need to put into the bank today? The question is, a simple question of solving this equation for P principal, right? But the answer is already given here. But this is a very basic mathematical logic. In other words, no matter the key to solving any equation, no matter how complicated, lies in identifying z equals x times y structure. Let's think about it. What does that mean? Let me take that out. Because this is the very basic structure in any equation. All equations, when simplified to the reduced to the simplest form, when simplified to the maximum, right? They must all be reduced to this form, and this structure is, basically something like, something we always use, like 3 times 4 equals 12. Think about it. We all understand that why 3. We know that 3 times 4 equals 12. And then starting from the structure, right, from that, we can find, see, this is like 12. 12 is 3 times 4. So think about it. We all know, if you don't know 3, right, if this 3 is the unknown, how do you solve for that? Right? You divide 12 by 4. In other words, if x is the unknown, you simply divide z by y. Make sense? And then when we have an equation like this, future value is, this looks so, please bear with me, because this is not writing. I'm not writing it. I'm drawing it with the mouse. So it takes really a lot of patience. Okay. Now, when you have a structure like this, an equation like this, you must be able to see the inner structure in it, or you must be able to identify the simplest structure. since I have already explained to most of you, it should be obvious. This is exactly in z equals x times y structure, isn't it right? P is x, and the thing in the bracket, the thing in the parenthesis is y. Okay? And then think about it. You want to know what P is, then what do? P is x, right? So if you divide z by y, then you get x. So the um, same reasoning, exactly the same reasoning. So then principle is future value over 1 plus RT. Make sense? Okay, then applying that formula, right? Now we can find the principle, right? So then principle is simply, dividing the future value by 1 plus interest rate times 20, right? 20 years, right? Hit enter. What do you get? It's $900. Well, and we already knew the answer because we started in the previous problem. We started from principal of $900, same interest rate, same number of years, and then that got us to this future value. So then, if you solve it in reverse, in other words, finding principal, if you want to find principal, it's exactly the reverse process of the future value. Isn't that right? It's exactly the reverse process. So if you solve it backward, in other words, in reverse process, you should get exactly uh, the same principle that you started with, right? In the original problem. So when you get the same principle as the original problem, then the formula checks out. Our formula is uh, immaculate. Our formula is correct and immaculate. Okay, it's confirmed, right? It's verified. And here, this cell automatically filled up, right? Because I had filled in the formula there. So this is the power of soft coding. Um, when you have other variables already, uh, found, then it's going to automatically also fill in this blank, right? Because it's not really a blank, but there's a formula already in there. Now, of course, you can also do that by simply uh, copying and pasting the formula above it. In this case, in the previous one, I found right? I found it this way. I found the interest this way. Now, so if you also, in the second row 13, principle can be found simply by replicating, right? The formula we found there, right? Okay, also here, I had that built in. Now, let's do this problem as well. We already know, right? Um, it would have to be $900, but let me use, that was also the same problem there. So in this case, let's try this. This time, Let's try this. So 13, this time, we do it uh, for 13 weeks, what's going to be, whatever what's the principal we should put in for 13 weeks or 0.25 years to have uh, this future value in 13 weeks. In 13 weeks or 3 months, right? I want to have this. When interest rate is 9%, what's the principal I should put in? Again, it's simply future value divided by, open parenthesis, 1 plus interest rate times t. But what is t? Is this t? No, this is t, right? That is, time has to be always in years, right? Hit enter. Don't expect $900 this time because it's not the same setup. Because in the previous problem, the time was 2 years, right? And then in this problem, time is 13 weeks. Now this is 180 days, and then if you just drag it down, it will have to be $962 at 8% interest rate. And if you put it for 180 days, which is 0.49 years, using exact interest here, you will get $1,000 exactly. Okay. Now, let's move on. I mean, there is something called 60-day 6% method. This is ridiculous, but I will come back to this later. I mean, this is really. Let's go to. Let's go to row 43. In row 43, what do you see here? Okay, I have when the time is given in something other than years, you must have have a separate column, another column, right? It wasn't because the problems in the book doesn't give it to you like this. It just gives you a verbiage, right? It gives you a verbiage. Like Jim Cramer put borrowed $500 at 9.99% APR for 120 days. So what should be, what is the interest he has to pay? It's just verbiage. They don't give it to you like this. This is something you'll have to build. And I've been telling you, this class is a training, right? This class is a boot camp, in other words, for your brain to develop the ability to see the structure, right? Mathematical structure buried in the verbiage, right? And the verbiage is trash. Actually, the verbiage is rubbish, right? Because if you can do abstract thinking, verbiage is nothing. What's important is being able to identify the structure of the problem hidden in the verbiage. You understand? Because that's the skeletal structure, and we don't need the flesh and fat. Because does the name matter? I mean, do we need to know Jim Cramer? Do we need to know who is making the deposit or who's borrowing the money? Doesn't matter. Let it be Mr. X. That's not an important thing at all. That's what I call fat, right? What's important is what is the principle, right? and what is the interest rate, for how long, right? As long as you can identify those things, and as I said, um, in the original problem, uh, in the book, right? Um, Basically, the scenario given is only this, right? And when you build the model, you will need to insert another column, right? So that the time would be converted into years, right? Um, so we have, and it's not difficult. We already know what to do. Um, and converting, and unless otherwise specified, right? We I said default is ordinary interest year, okay? And let's see which one has. And suppose, let's see, this was given as. For this one, let's use exact interest year. So I'm going to annotate exact year, right? Okay. So, okay. Um, so the interesting thing is, this row 43, we know what is asked, right? Interest is asked. So we already know what interest is, right? Interest is principal times 8 times t, right? There you go. And t is already, converted into years, right? We got it, right? 120 days. So that's exactly 0.33, 33333, it goes on forever, right? Now, in the second problem, okay, what is, you may be scratching your hair. What is it asking for? It's asking for time in years. So that means, everything else is known. Principal is known, interest rate is known, interest is known. And the question is, what's the time? First in years and then in days. Of course, if you find it in years, then we can convert it into days. And then third problem, interest is known, time is known, principal is known. Then the question is, what's the interest rate? We can solve for that. What's the principal? We know this, right? We already, because we've done that. So we're gonna do, but let's think about it. So here the question is, I put all the formulas there, but let's think about it. Going back to the basic interest formula, interest only is P times R times T. I don't like this. Okay. P times R times T. Okay. Now, suppose principal is the unknown. If the principal is the unknown, how do you solve for that? You might wonder. Well, I've been telling you, so professor, key to solving all equations, I've been telling you, is z equals, identifying z equals x times y structure, right? But in this case, how do we know? I mean, is it x times y times something else, w structure? There are, three variables. Yeah, you can consider that as three variables, right? But then, look, it's two variables, actually, if you think about it. It's two variables, right? Why? How can it be two variables? Look, it's like z equals, this is z, right? And this is x, and r times t is y. Isn't that right? Why? In a product means, you understand, multiplication, outcome of the multiplication. Does it really matter? I mean, in a product, in multiplication, whether you cut it like, suppose you have 12, and how did you get to 12? You got to, three times 4 is 12, isn't it right? But then, what is 2? 2, 4, what is 4? 4 is 2 squared, isn't it? Or 2 times 2, right? So, in other words, it's 3 times 2 times 2. Now, whether you call this, if you lump it up like this is 6 times 2. Or, depending on how you lump it, and then if you lump it like this, it's going to be 3 times 4. Isn't that right? 3 times 4, right? So, doesn't matter. I mean, whether it is 3 variables, 4 variables, no matter what, if you are, how you split it into 2 variables, x and y, it depends on what is your unknown variable. In this case, p is the unknown variable. So what do? This is p is x, so what do you need to do? You will divide, this is z, so I, that looks ugly. So it's going to be I divided by r times t, right? Makes sense? And by the same logic, what is r? R will be I divided by p times t. Okay, then what is t? How do you solve for time? You divide it by, you divide I, r times t. Yeah, this doesn't look nice, so let me, okay, let me draw again. Okay, that makes sense. Now, then we can do this easily. So here, to find, our goal is to find t. So t is then I divided by t times r. Okay. Now, don't forget, you have to put parenthesis in the denominator. Why? Now think about it. Uh, when you write it, to human eyes, it's quite obvious, right? Which one is denominator, which one is numerator. Also, but when you write it like this linearly, right? It's also obvious to human eyes. But then when you write, but to the computer, think about it. It's written linearly, but let's see. If I didn't put parentheses here, what's going to happen? What would the computer? How would the computer react to this? I mean, what would be the computer's logic? The computer doesn't know whether this whole chunk, this chunk is the denominator. It will just execute in the order written, right? So that's why you have to apply PEMDAS, right? You understand PEMDAS, parenthesis, exponent, right? Multiplication, division, right? Addition. So by putting the parenthesis around it, then the computer will recognize that this is the numerator and this is the denominator. The whole chunk is the denominator. Otherwise, the computer will, you will bungle up, right? And it is ultimately not the computer, but your responsibility. It is you who is ultimately responsible for your own outcome. You understand? All right. So you do this, and then next, if the problem, I mean, you can stop here, but the original problem was also asking how many days it will take. And all you need to do is, and in this problem, there was already, exact interest year was already specified. Then all you need to do is this times 0.86 year or 365 days. There you go. Right, in terms of days, 313 days. Now, you don't need these many decimals. Use only, by default, 2 to 3 decimal places, right? So what do? You can go to, this is what? Decrease decimal. So just leave, right? And some things, it's not rounding. Well, it should be rounding. Because it was 5 something, right? I don't know why it isn't rounding. Normally, Excel is set to round. But let's say, we'll leave it to 3 decimal places, but it can be rounded to 1. I will check the number setting later, because normally it would round to a 1, right? Now, next question is, what's the rate? Then the rate is, just the same. Interest over P times T. Okay, P times T. There you go. Then it's 8%. We got that. And what about this? Principal. Principal is then, right? That's the same. Interest over, right? R times 4, right? Number of years. go. That should be the principle. Now, so we have just two things left in this topic, and the next topic will be quite interesting. Before we do the next topic, we're going to be looking at 60 to 6% method. Now, so that's it for this video, this segment of the video. Stop